According to the National Electrical Code, specifically NEC 300.19, vertical conductors must be supported to prevent the weight of the conductors from creating excessive strain on the conductors themselves, their terminations, and any related equipment. For H0 copper conductors installed in a vertical raceway, the maximum distance between supports is 50 feet. This requirement is essential for maintaining the integrity and safety of the electrical system. The NEC provides specific tables and guidelines for supporting conductors in vertical raceways, taking into account conductor size, material, and the type of raceway being used. The purpose of these support requirements is to mitigate several potential issues. Firstly, the weight of long vertical runs of conductors can exert significant stress on the conductor terminations. Over time, this stress can lead to loose connections, which increase resistance and generate heat, creating a fire hazard. Secondly, without adequate support, the conductors can sag or move within the raceway due to thermal expansion and contraction or electromagnetic forces during periods of high current flow. This movement can damage the conductor insulation, leading to short circuits or ground faults. Thirdly, proper support ensures that the conductors remain properly spaced within the raceway, which is crucial for effective heat dissipation. Overheating conductors can degrade the insulation and reduce the overall lifespan of the electrical system. There are several acceptable methods for supporting vertical conductors. One common method involves using cable support grips. These grips are designed to clamp onto the conductor without damaging the insulation, providing a secure and reliable means of support. The support grips are typically attached to the raceway at specified intervals, as determined by the NEC. Another method involves using cleats or straps to secure the conductors to the inside of the raceway. These cleats or straps should be made of a non-conductive material to prevent the creation of ground loops or other electrical hazards. The selection of the appropriate support method depends on factors such as the size and number of conductors, the type of raceway, and the environmental conditions. When installing vertical conductors, it is crucial to carefully follow the NEC guidelines and manufacturer's instructions for the support hardware. The support intervals must be strictly adhered to, and the support hardware must be properly installed to ensure that it can withstand the weight of the conductors. In addition to the support requirements for the conductors themselves, the raceway must also be properly supported. Vertical raceways should be securely fastened to the building structure at appropriate intervals to prevent them from swaying or moving. The supports for the raceway should be designed to withstand the weight of the raceway and the conductors it contains, as well as any additional loads that may be imposed by wind or seismic activity. Regular inspections of vertical conductor installations are essential to identify any signs of damage or deterioration. The inspection should include checking the conductor terminations for looseness or corrosion, examining the conductor insulation for damage, and verifying that the support hardware is in good condition. Any issues that are identified during the inspection should be promptly addressed to prevent potential safety hazards. It's important to remember that the NEC is a minimum standard, and in some cases, it may be necessary to provide additional support for vertical conductors. This may be the case in areas with high seismic activity or in installations where the conductors are subjected to unusual mechanical stresses. In these situations, it is recommended to consult with a qualified electrical engineer to determine the appropriate support requirements. The NEC specifies the maximum support intervals for various conductor sizes and materials, and these intervals are based on extensive testing and analysis. Exceeding these intervals can compromise the safety and reliability of the electrical system. Furthermore, it's important to use only approved support hardware that is specifically designed for use with electrical conductors. The use of makeshift or unapproved support hardware can create a safety hazard and may violate local electrical codes. Ensuring proper vertical support for conductors is critical to maintaining a safe and reliable electrical system. By following NEC guidelines, using appropriate support hardware, and conducting regular inspections, electrical professionals can minimize the risk of conductor damage, overheating, and other potential hazards. Therefore, for H0 copper conductors in a vertical raceway, supports must not exceed 50 feet intervals, as stated by the NEC. Correct installation also involves considering the ambient temperature and directing factors. High ambient temperatures can increase the temperature of the conductors, leading to increased voltage drop and reduced current carrying capacity. Therefore, it is important to select conductors with an appropriate temperature rating and to apply the necessary deterring factors, as specified in the NEC. Additionally, the conductors should be installed in a way that allows for adequate ventilation to help dissipate heat. When multiple conductors are installed in the same raceway, they can generate more heat than a single conductor. The NEC provides guidelines for deterring conductors in these situations, and it is important to follow these guidelines to prevent overheating. The deterring factors depend on the number of conductors in the raceway and the ambient temperature. In some cases, it may be necessary to increase the size of the conductors to compensate for the deterring. Voltage drop is another important consideration when installing electrical conductors. Voltage drop occurs when the voltage at the load is less than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause equipment to malfunction and can also lead to reduced efficiency. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To minimize voltage drop, it is important to select conductors with an appropriate size and to keep the conductor runs as short as possible. Additionally, it may be necessary to use larger conductors or to install additional circuits to reduce the load on each circuit. The type of insulation used on the conductors is also an important consideration. The NEC specifies different types of insulation for different applications, and it is important to select the appropriate insulation for the environment in which the conductors will be installed. For example, conductors that are installed in wet locations must have insulation that is suitable for wet locations. The insulation should also be resistant to chemicals and other contaminants that may be present in the environment. The NEC also provides guidelines for grounding electrical systems. Grounding is the process of connecting the electrical system to the earth, which provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. The grounding system must be properly installed and maintained to ensure that it is effective in protecting people and equipment from electrical hazards. The grounding conductor must be sized according to the NEC, and it must be securely connected to the grounding electrode. Regular inspections of the grounding system are essential to ensure that it is in good condition. The NEC also addresses the use of overcurrent protection devices, such as circuit breakers and fuses. These devices are designed to protect the electrical system from overloads and short circuits. The overcurrent protection devices must be sized according to the NEC, and they must be properly installed and maintained to ensure that they function correctly. The overcurrent protection devices should be tested periodically to verify that they are operating properly. The NEC is a comprehensive set of standards that covers all aspects of electrical installations. It is important for electrical professionals to be familiar with the NEC and to follow its guidelines when installing and maintaining electrical systems. Failure to comply with the NEC can result in serious safety hazards and can also lead to fines and other penalties. The NEC is updated every 3 years, and it is important to stay current with the latest edition. Electrical professionals should attend training courses and read industry publications to stay informed about changes to the NEC. In addition to the NEC, there may be other local codes and regulations that apply to electrical installations. It is important to be familiar with these local codes and regulations and to comply with them. The local codes and regulations may be more stringent than the NEC in some areas. Therefore, to reiterate, for H0 copper conductors and vertical raceways, the maximum support interval is 50 feet. Understanding and adhering to this requirement, as well as all relevant NEC guidelines, is crucial for ensuring the safety and reliability of electrical installations. Always consult the latest edition of the NEC and local codes for specific requirements and updates.